Hi everyone!
Hi!
Welcome to another MSI Insider live stream. Today I'm not alone, I'm here together with Peter.
Hi!
Peter is one of our technical experts here at MSI. Because today we're not only going to talk about water cooling. I know, of course, everyone is looking forward to water cooling, but to demonstrate performance, we decided to do a second topic today, and that's the performance benchmark of the 10th generation Intel Core processors, of course, on a very nice Z490 motherboard. So if you're also excited about looking into the performance of this new generation, they were actually, I think, 1 hour ago was when they were officially launched by Intel. So when all the performances went live and stuff like that.
Yeah, an hour and 7 minutes ago. Yes.
An hour and 7 minutes ago. So very fresh. We will show performance, we will talk a little bit about performance of 10th generation and also how you can improve performance on the 10th generation Intel Core processors using better cooling basically. Because cooling is the main topic today. We actually made this promise 2 weeks ago that we would do an unboxing of this MAG CORELIQUID 360R all-in-one liquid cooler.
Yep.
And actually we were going to unbox it last week, but I heard Eric broke his promise. So now Eric is not here, but I'm here, so I want to stick to that promise. So today we'll definitely unbox these CPU coolers. We will install them on a demo setup, and we will talk about them and show them in depth, literally.
Yep, that's the plan.
It's a good plan, right? Also, we have a giveaway today. So if you go to msi.com/2/insider, you can participate. We'll give away several $20 US Steam Wallet codes today. So make sure to tune in. I see I have some problem with our giveaway website, so I hope it works, but I hope later on I will be able to draw some winners. Let me see, I see some questions in chat about the pump. We will definitely talk about the pump today.
Yep.
And we will actually really give you an in-depth inside of the pump, so make sure to check it out. I see some discussion about the pricing. We will also talk about that later. I see many topics you're already talking about that will be included in this live stream. So yeah, let's first start with the cooling itself or with the unboxing.
Now we start with the outside of the box.
Yeah, that's always a good idea.
Yeah,
so
I
there
think
are
so.
two models, the MAG CORELIQUID 240R and the 360R.
The 240R, yes.
Yeah, you can already see it in the size of the box. The radiator is obviously bigger on the 360R. It has a 360mm radiator with three 120mm fans on there, whereas the CORELIQUID 240R has a 240mm radiator with two 120mm fans. So yeah, that's the obvious difference between the two. But I think most people are very curious about what's on the inside.
Oh, the inside of the box. I think this is the most interesting one, the bigger one. It looks,
bigger one, also more powerful, of course.
Yes, and this is the one we're going to install on a test platform later today.
And we have a cool CPU for that, right?
Yeah, we got a very cool CPU for that. Oh, it will be cool with this cooler on top.
Yeah, and it will be faster with a cooler on top.
That's the plan.
I see some more questions about the price. Yeah, later on we'll give you an overview with the prices in euro and US dollar to give you a better idea about different models, how they relate to each other in terms of price. So yeah, kick it off with the unboxing. I think everyone's curious to see what's on the inside. Brand
new plastic is still on it. Taking the knife.
Be careful.
Should be fine. I'm not Eric.
Yeah, then it will be a problem if there will be a knife.
Let's see. A little bit. Oh, more seal here. Yeah, let's see.
It's a pretty big box.
It's
of course, big radiator means big box. And also important, if you're going to use a 360mm radiator, your case has to be suitable to fit a 360mm radiator.
The inside of the box.
So what do you see? A user manual, always very good.
Now a quick installation guide.
Quick installation guide.
A lot of text, but also pictures. Pictures how to install it.
So it's not very difficult, right? Later on we will also, we're not going to build it completely in a case, we will use it in a test setup, but we will show you how to install the block on the CPU.
Yes. So, quick installation guide, don't need it. I hope. Yes, a set of fans. 3 in this case, because...
Crazy gamer. He didn't get the Steam code for last week. I'll make sure. I think last week Eric and Ja did the stream, so I'll make sure to check with them what went wrong.
All right.
So we'll look into that. So 3 120 millimeter fans, ARGB fans.
ARGB. And every fan, oh, it's a lot of wires already. Look. Whoa. But that's because every fan has 2 wires.
So one for the fan itself, the PWM connector, the 4-pin.
Yes.
And one 3-pin connector for the addressable RGB lighting. So that's the one you plug either into an addressable RGB hub or directly on the motherboard using the J-Rainbow header in this situation.
Yep. And every fan has a loop cable for connecting the extra fan. So this one you plug on your motherboard. And you got here 3 pins.
So even if you have a motherboard with only one addressable RGB header, one J-Rainbow header, then you can still connect all 3 ARGB fans.
You connect them all together, so you can light them all up. So you don't
Magni is asking, does the pump logo spin like on CES? Yes, it does. We will show you later. Definitely, it does. It does.
It doesn't spin automatically. It's hand operated.
But yes, you can turn it.
Yes, you can spin it. We'll show you.
So 3 fans in there. I can already see the fan blades are.
Yes.
They're like carvings in them.
Yeah, they're really serrated edges on the back side. You don't know if the camera can pick that up. Really difficult. Can you see it?
Yeah, I think it should be visible.
But there's some teeth on the back side.
So that's really to get maximum efficiency.
Yes, better airflow, better pressures.
And lower noise levels.
Of course. It has the fans have rubber pads on the sides, so to reduce vibration. So that's really nice.
Brian is saying in chat, I'm always scared with water and technology. Let me see, chat's going a little bit too fast. I know it's not conducting, but I will be after. But I will be after some use. Yeah, usually, especially with an all-in-one water cooler like this, you don't. Today we're going to do it, but you don't usually open it up. You just install it. So there is no risk of accidentally not tying the fittings correctly or something, which of course is a risk of custom water cooling.
Yes.
But yeah, I would say all-in-one water cooling, it's very easy to use. I think everyone who can build a PC should also be able to install this. It's really easy, and it's less risky than when building a complete custom loop.
Yes, the water is inside, you never have to refill it, so it shouldn't be any problem.
Yeah, it's very, very easy.
Very, very easy.
And it's maintenance free, so that's
yes,
also very, very convenient. You don't have to refill it or stuff like that.
But there's more in the box, not only 3 fans. I think the most important part, or one of the most important parts, is this. It's actually...
Yeah, Raklarak's also asking, the cooler will need maintenance? No, it doesn't need any maintenance. Completely maintenance free.
It's made out of 3 major parts.
I see a question in Twitch chat, will this cooler be in a giveaway? It was actually, not today, but 2 weeks ago we had a Z490 motherboard live stream where we gave away one MPG Z490 gaming carbon Wi-Fi motherboard as well as the MSI CORELIQUID 360R water cooling.
Okay. That was a nice
a cool prize, yeah. We had a very happy winner, so always good to see.
Inside, we've got a big radiator, 2 hoses connect to it, and the water block. And somebody was asking, does it spin? Yes, of course it does spin. Oh, here, see. But it's hand operated, not automatically. Of course not. No, so you can position it any way you like. So like, is it like this? Oh yeah, then you can turn it exactly like that.
Yeah,
or
so if you
hold
put it
like
on
this.
sideways, if that's like, for example, easier in your build, because the tubes are going in a different direction, that can sometimes make it easier. But you don't want the logo to be upside down or sideways, so you can just spin it in the preferred direction. And it spins to 270 degrees, so it's very easy in any direction to get it straight up.
Yep. Indeed, indeed. There's more in the box. There's more in the box.
Ooh, the mounting systems.
All the different mounting systems.
Yeah, so later on we'll also show in detail for which platforms this cooler is suitable. So now we're reviewing the 360mm model. Will be slightly different in terms of compatibility compared to the 240mm. Later on we'll show you a clear overview of which cooler is compatible with which platform. Well, chat is going. For some reason I get all chat messages twice.
Oh.
Let me open up
That's nice.
chat again. Because that's why the chat goes very fast, because everything displays twice for some reason.
Somebody's asking about B450. No B450 today. Only Z490.
I saw a question about fans, but I cannot find it anymore.
Fans. Yeah, they look white now, but they are fully RGB. Addressable RGB.
Does the pump have customizable LED? Yes, it's also
Yes, it will connect to
compatible,
this.
all Mystic Light compatible. Like all the RGB lighting you see on here will be controllable through Mystic Light, or if you desire, you can also switch it off. It's totally up to you.
Yes, the pump has the same headers as the fans. So the normal header to connect to your motherboard and another header to connect to an extra, to the fans or to another.
To do daisy chaining basically.
Daisy chaining indeed.
So with one connector, you only need one addressable RGB connector on your motherboard, and with that you can control the full RGB setup on this all-in-one water cooling. So there are actually like 4 RGB components basically on the model that we're now unboxing. So you have 3 of the fans and the water block, but you can all daisy chain them to each other, so you only need one connector on your motherboard. So the CPU block with a copper plate.
Yes, a copper-plated CPU block. There's protective film on it. There's no thermal paste here on the block pre-applied, but you get a little tube of thermal paste.
Make sure to use that tube of thermal paste.
You don't want to use
install it without.
You don't want to use it without.
No.
This is a special radiator because it has a black square here in the middle, and that's where the pump is located inside the radiator. So the pump is not inside the water block, but it's inside the radiator.
Yeah, and that has multiple reasons. First one is that it's patented to use the pump in the CPU block. So we had to search for a different solution. So we put it in the radiator, and we actually found out that it also happened to reduce the noise levels. So yeah, that's where the pump is. Later on we'll also show you in more detail about what it looks like on the inside, how the pump works.
Indeed.
I see a question in chat, should I apply the paste in the CPU or on the cooler? I would always recommend to do it on the CPU. It's easier. It's steady on your motherboard. So yeah, usually it's easier to do on your CPU. Of course you can do it on the cooler. It works basically the same.
Yeah, but the CPU is smaller than the base plate of the cooler. So if you apply it on the cooler block, probably it will be over the CPU.
If you already spread it over the complete block, then it will. But for example, if you only apply it in the middle, because with the pressure you will also spread the...
it depends what your preferred method is of applying thermal paste. Some like a big blob in the middle, some do axes, some do lines.
What do you do usually?
I normally do a big blob in the middle.
Yeah, I'm also of the...
But sometimes also for the bigger CPUs I do multiple blobs, like for the
Yeah, I do the same for Threadrippers and
yeah.
Also the X299 platform. There I also do it.
Yeah, for the X299 normally you use a cross method.
And why do you use the cross method?
I like it. It's something different.
Using different techniques of applying thermal paste.
Yeah, different techniques. Yeah,
Keeps it interesting.
A lot of people already have done tests with it, and in the end, if it covers the CPU, it's all fine. So there's no better or worse method to do it, but as long as it covers the CPU,
it works. Indeed, as long as it's fresh thermal paste, that's important, and make sure that it's properly applied, and you can use different methods. That's all fine, but don't use like extremely little thermal paste or a whole bunch of thermal paste. Like just keep it modest, I'd say.
If you use too much thermal paste, it's not a real issue for cooling, but it will leak over your CPU.
It will basically get messy.
And it's messy, and it just make a big mess. So don't do that.
And it doesn't make sense. It will not help your cooling, so there's no need to do it. So yeah, just use whatever is needed to properly, have the basically the CPU covered, but not outside of the CPU.
Yes, indeed.
Diablos is saying I use dot or X, both works fine. Yes, it
yes,
both
indeed.
Works fine.
Yes.
Zuloma is asking, so you can daisy chain the pump to the fans as well, since it's on the radiator.
You can daisy chain
the RGB lighting. You can daisy chain.
Yes, because this is the RGB connector, and there's a little cover on it that you remove, and then you connect it to the fan, and then you can daisy chain the fan again to the next fan.
And like this, your motherboard is able to control different addressable RGB devices over only one addressable RGB header. Yeah,
so you don't need 4 addressable RGB headers on your motherboard.
Exactly. But one important thing here is if you, for example, want to do different effects on different fans, then you do need separate headers. Because when you daisy chain them over one header, and if you use a certain effect in Mystic Light, in Dragon Center, then the effect will apply to all RGB devices in that specific daisy chain, because you control that specific JRainbow header.
That's correct. But most people want it all the same, right?
Yeah.
They don't want a big mess of lights in their computer, or do they?
I see a question in chat if we will also show to apply the thermal paste later on. Yes, we will install this CPU cooler on the test bench later on, and we'll also show to apply some thermal paste on there.
Yeah. What's next?
Caesar is asking, why is there a plate screwed at the top part of the radiator? That's the pump. I think that's the part where it's talking about.
Yeah, the pump is hiding behind this plate.
So it's integrated in the radiator. And there's also a reason why it's specifically in that place. So we will talk about that later. Why it's not, for example, at the very top.
Not now?
No, we can do it. Yeah, now you have everything open, so it should be okay. Maybe you can put the 3 fans on top of the radiator. That's probably the best way to demonstrate
like this. Yeah. So you put one here. That does make sense. And you put one here. And a third one exactly here. And if you can see, all the different cables.
And that's always the downside of RGB. You have to do a little bit more cable management because you have more cables.
And as you can see, this last fan is the motor of the fan is exactly covering the motor or the pump of the radiator.
So where the fans will actually move the air is always on the outside. That's where you have the static pressure. Yes. And in the middle, there is basically no airflow in the fan. There's also a piece of plastic on the back of the fan where the fan is attached to. So the cooling will happen on the outside of the fan. So that's why the pump is in the middle of one of the fans, because it will not cool there anyway.
Yes, indeed. So also on the fan here, there's a radiator part here in the middle, but it will not almost get no airflow. So to have the pump here, it's no big loss at all.
Arrows Mine is asking, since the fan is in the radiator, isn't there a higher risk on getting a leak? You mean the pump in the radiator? No, this is not an issue, a bigger risk for getting a leak.
The whole radiator has water in it, so it doesn't matter if the pump is here or on the other end, or not in case of any leaks and whatsoever.
No, that's definitely not. It doesn't make a difference. So in terms of leakage, each method is fine. It can be in the water block. It can be in the radiator. As long as it's properly manufactured, then there is no risk of any leak, whatever method you use.
True. And as far as I can tell, this looks proper manufactured, so no risk of leaks.
Yeah, I don't see any leakage on the.
No water.
You didn't spill anything. Later on, you will do that, right?
Yes, later on I will.
That will be on purpose. That will
be on purpose, indeed. I hope I don't spill too much, though.
Yeah.
Yes.
So what else in the box? Where you have everything out?
Oh yeah, we've got. Oh, gee. Don't eat this. Don't eat the silica gel.
It's not tasty.
Should I try?
Maybe not.
No, maybe not.
Not recommended. Not recommended.
But that's everything in the box.
Okay, so we have the mounting, and there is also a small fan cable in there, right?
There is this fan cable.
Yeah, we will talk about that later. Special cable, and it can make a big difference in one certain topic.
Yes.
So yeah, let's maybe look into a little bit more what the specifications actually are of this all-in-one water cooler, also what it can do, how it is designed. We already touched on the radiator pump design. So instead of having the pump inside the CPU block, what is quite common for other CPU coolers, in this model it's integrated into the radiator. And on the slide you can also see an exploded view of the pump, so how it is assembled. You can see the motor in there, but of course this is just a render image, and it's always nicer to see it from the inside. So Peter, I think we should open that pump up.
Yeah, but I'm not going to open up this one because we're going to use this one for testing later on. But we're going to open
we have
up
another one, and the pump on both of them is the same. So.
Yeah, we're going to open up this one.
So the 240R.
Yes.
CORELIQUID.
So I'll put the big one on the side. Let's see. And then we're probably going to make a mess with the smaller one. Let's see.
Yeah, so essentially these two all-in-one water coolers are the same apart from the size of the radiator. So the CORELIQUID 240R, it's got the same kind of design. It also has the pump in the radiator. It also has the CPU block where, with the rotatable head.
The difference, only two fans.
Only two fans. Yeah.
Only two fans.
So also fresh in the box.
Fresh
and
in the box.
And you're already going to destroy it. Later on it should be usable again, right? If we fill it back up?
Yeah, if you fill it back up, we should be able to use it again, yes. Let's see. Similar pump. Similar pump. Don't forget, this is the pump. Similar water block, but only a little bit smaller. And this one, we're going to open up the pump. And I've got a little bit of plastic box handy because there's water inside and you don't want to have it everywhere.
Jesse is asking, can we buy those exact radiator fans separately as case fans? I'm not sure if they're also separately available right now, but I believe we will have some separate addressable RGB fans available separately in the future. So Yeah, I would say in the future, yes. I'm not sure if we already have, but
I haven't seen them yet, but yeah, it would be nice to have a complete set of all the same fans, right?
and also, for example, if you want, it's nice if they're available separately, because if you want to do a push-pull configuration on your radiator, you can just put 2 or 3 extra fans on it based on the model you have on each side of the radiator to increase your performance further.
Indeed, indeed. Now let's try to open this without making a big mess. Probably
Only a little mess.
only a little mess. I know for a fact the first plate is only a little bit of a cover.
So don't do this at home. You don't.
That's what I want to say. Don't do this at home.
You don't need to do this to assemble the cooler. This is just to show you the inside of the all-in-one liquid cooler. But the cooler itself is well assembled and does not need any maintenance or anything. So no need to open it up. Yeah. Just keep it as it is. Just install it and use it like that.
Yeah, we do this for you, so you don't have to.
Yeah, exactly. Okay, my giveaway system is working again, so it should be fine later on when drawing winners.
Cool. It will be a bit weird, but here in the middle is a green PCB, and our green screen will.
Yeah, we have chroma keying, so that's a little bit difficult.
Yeah, so imagine this
looks funny.
as green. But this is the wires to the pump, and they connect to the pump itself. And now I'm trying to open this without making a big mess still.
Because with the next layer you will reach the water in there, right?
Yes, yes.
The coolant. Arrow's Mind is saying, I guess he's doing the 240mm over the 360 due to the value. Yes. No, that was not really an issue. It's that the 360 we'll later use for demonstration purposes. So it was that we were going to use the 360 for something else already. And if we open it up and take out the liquid, then
it won't work.
It won't work. So that was the reason why we're opening up the 240 model.
Yeah, we only got 2 here in the office.
Yeah, we got 1 of each model, so.
Yeah, that's it. And we were breaking 1 of them, so.
I'm not breaking it.
Oh, no.
Not breaking.
Just tearing it apart.
Exactly.
That's also what Eric always says. Like.
No, Eric breaks it.
Oh, yeah. But
we take stuff apart, Eric breaks it.
All right, let's see.
The next layer.
Yes, this is.
And this is where you reach the coolant, right?
Let's see. Let's do it a little bit closer.
We can already see it dripping.
Yes, this is the pump motor and the blades, propeller blades. This will make sure that the coolant flows through your system. And if you look inside here, it draws coolant from the middle hole down there, and it spills it out to the holes on the side, but you cannot see it here. It's too dark. But we're gonna empty this one. Are we? Yes, we are, right?
Yeah, it's fine. We can empty it.
And this will probably make a little bit of a mess. And it doesn't look there's a lot coming out. It's only a few drips. But there's a lot more inside, but the air...
But of course, because it's off, it's not pumping through.
See? Now it works.
So that's why you're also shaking with the cooler, right?
Yes.
To get everything.
To get the air inside and the coolant out. But there's not a lot of water inside. I think only less than a cup of water. Half a cup, maybe. No, not even that. It's just a little bit of a bottom of water. Here. Can you see?
Yeah.
Yes, only a tiny bit of water.
So is it completely empty?
No, probably not, but we'll find more water when we open the other side, because we are also going to take off the copper plate, the cooling plate. You cannot see a whole lot more here on the inside. You can see the little hole where it draws in the coolant from the middle maybe you can see the little form where it's. No, I don't think it will show.
Maybe if you keep it closer to the camera, it might work.
Yeah, maybe. Leaking over the table a bit. Yes. See, still more water.
Yeah, if you keep moving it, it looks like still some water is leaking out.
Yes, it is. And don't drink this.
Tigio is asking, can you later show the structure of the cooling plate inside the cooling block? Yes, we'll also take the CPU block
Yeah, I'm going
apart.
to take off that one right now, actually.
So let's take a look inside.
And haven't seen that one, so this should make a bit of a mess also. Let's see. Aha. Those are a bit tight.
Bigger screwdriver?
Maybe.
So this block has got significantly more screws than the pump.
Yeah, the pump has only 4 screws to hold the pump in and 4 to hold on the cover plate. These one have 8 screws. And as we said before, you don't have to do this at all. Actually, if you do this, it will probably void your warranty.
Probably, it will surely void.
Oh, it surely? Yeah, it surely will.
Yeah,
No,
don't take apart all-in-one liquid coolers.
Yes,
you
don't do this.
My chat has got some issues. Let me restart it again. Should be able to be back. So maybe while you continue, I can draw our first winner of today's giveaway.
Oh yeah, that's
So if
fine.
you haven't participated yet, go to msi.com/2/insider. There you have a link to our Gleam giveaway. Our bot also spams it in the chat once every 6 minutes directly to Gleam. You can perform certain actions there. The more you perform, the bigger chance you'll have to win. You only have to enter once today. So if you are already enrolled in the giveaway, you'll automatically be included in multiple drawings. So even if you don't win the first time, you don't have to sign up again. And our first winner of today is still drawing.
Dun-dun-dun-dun.
Well, the notebook has a hard time finding the right winner.
Is there a winner?
I think we don't have a winner today.
Oh no!
Hello, notebook.
No winners?
According to the notebook, no winner so far. It says drawing winner for 20 seconds now.
Did nobody enter this?
Well, we have many entries, a couple of 100 entries. So
Okay.
should
That's
be
good.
okay.
That's good.
Should be okay. But we can continue with the block while the system is drawing a winner. So we'll get back to you with the winner.
Yes.
So you finished screwing out all 8 screws?
Yes, I finished them all.
All unscrewed?
All unscrewed. Let's see. Ooh. This looks really cool.
So this is the copper plate. And as you can see, there are maybe it's a little bit hard to see. Yeah, like that is better. You can see they're all extremely small fins. They're called micro fins. And they help to increase the surface area, which helps for your heat dissipation of the cooler. So it's easier for the cooler to transfer the heat from the copper block to the coolant. So to the liquid that's inside the cooler. So actually the liquid goes through all these extremely small fins.
Yeah, they're very, very tiny.
Yeah, it's really hard to show on camera, but I think it should be slightly visible.
Yeah, it's kind of even closer. Oh, maybe, yeah, like this, a bit.
Yeah, now it's visible, it's visible. Caesar's asking, is there a design decision to have the pump on the radiator, not on the block? 2 reasons. The first reason is because of patent issues. The second is that in our situation, it actually helped with the noise that the cooler produces. So with the pump in the radiator, it was less noisy than when having the pump in the CPU block.
Yes, indeed. This is the cooling plate. And
the block itself.
This is a...
So that's a piece of rubber there, I think?
Yeah.
To seal it all?
I think also it has a hole in the middle, so the water flows, it looks like from the middle to the outside. Like it flows here in the middle in and on here and there out. And in the process it's forced through all the little fins. So that makes great contact with a copper cooling plate.
My giveaway system is really struggling today. I don't know why, but I think Gleam is not working properly today.
Oh no. This should be.
But it is registering all the participants, so if it doesn't work today, we can always draw the winners later. So we will definitely still continue with the giveaway. But yeah, I can just not see who won, which is a bit of a pity. So that's the rubber that seals the CPU block from the copper plate, right?
Yeah, it makes sure it doesn't leak. It also makes sure it's for proper water flow through the through the water block. Like you can see the big hole in the middle and the smaller holes on the sides. If I put this over each other, you can see it's forced in the middle and flows out through the sides.
I see Michael's asking how long is the warranty. I know for sure that it's 2 years in Europe, but this might differ per country. So make sure to check it with your local retailer before you buy it. He should be able to communicate the warranty in your specific country.
Let's see.
How to enter? You can go to msi.com/2/insider, or you can use the link that's spammed in the chat. I will also use the comment to drop it in the chat right now. So that will give you a link directly to Gleam. I'm sure this works on YouTube and Twitch. I'm not sure if the bot can also post it in, for example, Periscope or Facebook. So if you want a direct link, make sure to use YouTube or Twitch for that.
You can also see the flow channels in the water block, because water comes in here through this pipe, flows here through this channel, is distributed along the length in the middle, then it flows through the block to the sides, and it comes out here, one on the other side, and it flows back to the radiator when it's warmed up. The radiator cools it back down, and cold water comes in back on this side. So it's quite an easy and simple design, right?
Yeah, but that's also why, the rubber piece there is also why you shouldn't take it apart, because if this is not applied properly, that will cause leakage, because then the coolant can escape your CPU block, and your CPU block is directly on top of your CPU and your motherboard, so you don't want any leakage there, because it can destroy both your CPU and your motherboard.
Exactly. And there's not a lot of water inside. I think I've got it.
And also now the pump is not flowing, so I think a lot of water is also still stuck in the radiator, basically, because you're not pumping it through.
Probably. Nah, I think this is about it.
But in general, in an all-in-one system, because everything's integrated, you don't need a lot of coolant. It's also just cooling a CPU with it, so it's not a whole loop like in a custom loop, where it has to flow through sometimes even multiple radiators, through the GPU, through the CPU. So that makes a difference in how much coolant you need in this situation.
Indeed. There's no big reservoir.
People are talking about the 5 meter distance. You mean 5 centimeters? No, we're actually 5 meters apart from each other.
He's not
I'm
here.
not physically here. I'm around the corner from Peter.
He's about
so we just
3
pasted
meters
me
away.
in here. I can have myself disappear, for example. So I'm not physically sitting next to Peter.
Nope.
I see more questions about the price. Later on we'll talk about the price for all different models.
Wizard. Yes, he's a wizard.
Yeah, so that's the inside of the MAG CORELIQUID water coolers.
This is a nice keychain, right?
It would make it's slightly big for a keychain though.
Is it? But really cool.
Yeah,
There's so many small fins.
But I think if it's in your pocket with your keys, you will damage the fins probably because they're so small and thin.
Probably, but still, will be cool.
Still looks cool.
I don't know how many, but they're so small you cannot even count them. Could be like.
If you start counting now, you might be finished by the end of the live stream.
Oh yeah, I should do that then. No, I don't know, but it should be close to 50, maybe.
Yeah, probably
100
on very small. Like how wide is it? Like 2 centimeters, maybe.
Yeah, that's about 2 centimeters. So it's really high fin density.
So maybe let's talk a little bit about the radiator design, because also internally the radiator is slightly different from what radiators look like in general in terms of layout. So on the left you can see that it has a split liquid pathway. So it's not that it's one half where the hot coolant runs in and on the other side runs out through the other half where it's cool. But in this situation, the hot liquid comes in from both sides and it also runs through the radiator on both sides. And then it turns around at the end and it leaves through the middle. So when it's already cooled down, then it flows out of the radiator again through the middle. So maybe we can show it up close. You can maybe show where the hot liquid runs in.
It runs through this pipe here. It divides in 2 sides to here. It runs down all the way to the ends.
So both sides of the radiator, not in the middle, only the sides?
Only the sides. And then flows back in the middle, through the pump, and then to the middle connector back to the water block.
And then I think you should grab a couple of fans, because let's explain why this matters. Because this increases your cooling performance by having a layout like this. So we already talked about why the pump in the radiator is specifically in dead position. That's because you have like a certain dead zone in the middle of your fan, where it's not moving any air, because that's where the fan is mounted in its housing. So yeah, maybe if you can turn the fan around, then you can see the middle of the fan with the plastic part, you won't have any airflow there. It will all be around it. That also means that on the sides, because this is the middle part of the fan, so the fan cools better on the sides than on the middle part. Oh. So that if the hot coolant goes into the radiator on both sides, it will be cooled more efficiently, because you will run the hot liquid exactly through the airflow parts of the fan, the better airflow parts of the fan, basically.
Yes, and it runs slower on the sides because it's double the area.
Exactly.
So it runs slowly, the warm water on the sides. So there's plenty of time to cool down, and then it runs the cooler water through the middle to the pump. Yeah.
So that's why. That's how like the radiator looks like on the inside, basically. Of course, this is way harder to show because. We would have to take the whole radiator apart, and that's a little bit more complicated.
Yeah, I don't have a big saw here.
I don't think we have the equipment here to do that, and it's also maybe not a good idea because you might lose a finger or two. So that's why we show you the image so you can see how the liquid runs through the radiator. It also has evaporation-proof tubing, so it's not like in the very beginning of all-in-one water coolers you just had like the rubber tubing. But here there's also a sleeve around it. Let me show it up close. And for example, if you have like sharp edges, for example through cooling fins or whatever you have in your case, and you run your tubes into one of these heat sinks, you might damage it. It can cut the tube. If you cut far enough, you might even cause leakage. So the tubes are protected by a sleeve around there. But they're still very flexible, so you can still move them in all different directions. So also if you want to install your CPU block in different direction, you can just turn it, and of course turn the logo with it on the block.
Oh yeah, of course. Don't forget that.
Some people are talking about the fans. Later we'll talk more about the fans, about also the fan speed and how you can reduce it and what it does to noise levels. People are saying the image is better. Okay, let's get back to the image. Maybe easier to see what it all looks like. Let me see if my giveaway system is running again.
I hope so.
Oh,
we should have some winners.
It says something went wrong.
Oh no.
Okay, we'll try again later. Okay, so that's it for the radiator and the tubing. People were already talking about the fans, so maybe let's make that our next topic.
Fans.
The fans.
Yeah, we got loads of fans.
Loads of fans. Depending on the model, the 360R comes with 3 fans, of course, because you have a 360mm radiator. So you need 3 120mm fans for that. They all come included in the box. And the 240R, which has a 240mm radiator, comes with 2 120mm fans. All fans are the same. They have a dual ball bearing, and this is because of the durability. They're very durable, they're also very silent. And the life expectancy of these fans is over 70,000 hours. So you can use this for a long, long time before wearing out your fans. It also has addressable RGB, Mystic Light, and addressable RGB basically means that you can also show multiple colors at the same time within your fan, for example. So you can do all different kind of effects. For example, if you have if the fan is blue at that moment, you can have a red effect spinning around through the blue. If you have a regular RGB device, it can only do one color at a time. So you can, for example, make your fan blue or red or green, but you cannot use combinations of the two. So these are all addressable RGB fans, so you can also use the features of addressable RGB. They're also PWM compatible, so if you connect them to a PWM compatible connector on your motherboard, it will adjust the fan speed based on the temperature. So if the temperature rises, the fan speed, the fan will spin up. It will spin faster to make sure it cools better to get the temperature down again. And maybe we can show them up close again so you can see the special fan blades that they have to really have the most efficient airflow with the static pressure you need to push it through a radiator. So better airflow, lower noise levels. So if you have any questions about the fans, just drop them in chat and we'll try to answer it. OPEC-man is asking, I want to know if the 360mm model is enough for the new 10-core CPU from Intel. Kind of want the Z490 godlike motherboard. Yes, today actually we will use the 10-core CPU from Intel today. Yes. So the Core i9 10900K. So that's a 10-core CPU with hyperthreading, 20 threads. And we will actually use it today with the 360mm model.
We're going to use this exact same radiator.
Exactly. We're not using a godlike motherboard today. We're using the Ace. But yeah, you can definitely, later on in the stream, you can see how it runs with that processor. We're even going to overclock the processor. So yeah, if you're curious about what temperatures to expect with the 360mm model and that specific processor, yeah, you will see it in a couple of, what is it? Maybe an hour?
Maybe.
Half an hour, an hour?
Half an hour, I guess. Yeah, about half an hour.
Caesar's asking, what does MAG mean? It means MSI Arsenal Gaming. So we have 3 segments, MSI Arsenal Gaming, which is a more affordable segment. Then you have MPG, MSI Performance Gaming, like the mid-range segment basically. And then you have the enthusiast products, MEG, MSI Enthusiast Gaming. So yeah, and let's continue to the next topic.
The fans. Yeah, we had the fans.
We had the fans. But in the this is exclusive for the 360mm model. You already see 360RH as well. That's a model with the hub. We will talk about that later. But this is specifically included in the coolers that have a 360mm radiator. And it's a very small cable, but it does quite a lot. So it's a 4-pin cable. So this is where you connect the fans to. So usually you interconnect the fans.
You connect one side to your motherboard.
Maybe you can show the other cable as well, because there's like a splitter where you can connect all 3 fans.
Yeah, there are multiple cables. Just to make it confusing.
So there are two cables included. The other one is always included, also with the 240 model, but then it of course has 2 connectors.
Yeah, you got a tiny cable with only a male and a female side. Then you got the bigger connector with 1 female side and 3 male sides. And one side you connect to your motherboard, and the other side you connect to all your 3 fans. So you can have only one connector on your motherboard to connect all the 3 fans to it. And they run at the setting on your motherboard.
And they also all run at the same speed. Then.
They will all run all at the same speed, yes. But that's actually what you want, in most cases at least. And, but on some motherboards, for some brands, you cannot control the fans exactly as you like. And then you can use the tiny cable, and this will reduce the fan speed. And when you reduce the fan speed, you will also reduce the noise. And that is the big benefit of this little tiny cable.
Yeah, so this comes included with the 360mm models. And in this table you can also see the difference that it makes. So this cable reduces the fan speed from 2000 RPM max to 1500 RPM max. And in the table you can see an example of the cooler running at 2000 RPM, where it runs at a little over 44 decibels. And with the noise reducer cable in between, it will only produce a little over 35 decibels. And as you can see at the temperatures, it's only a minor increase. Of course, this will slightly cost you cooling performance, because when the fans are running at a lower speed, they will not move as much air as they do on full speed. But still the difference is, I would say, it's not very big. So if your CPU temperature allows it and you want to have more silent system, then you can put this cable in between. Also, for example, if in your situation maybe the 240mm radiator is sufficient to cool your CPU, but if you want to have a more silent system, it might still be worth it to for example, get the 360mm model, install this cable so the fans spin lower, but you still have sufficient cooling capacity, but at a lower noise level. Tudor is asking, what is the CPU? In this example, it's the Core i9-10900K CPU on the Z490 Godlike motherboard.
No, Z490 Ace.
No, in this example, the testing example.
Oh, the testing example, yes. Oh yeah.
Later on we will test it with the Ace today, but in this example it's on the Godlike. But for the temperature of the CPU, it doesn't matter whether you use the Ace or the Godlike.
That's true.
So the noise reducer cable will have the same effect. So it will reduce your noise by approximately 20% when using the cable.
Indeed.
So then compatibility of the all-in-one liquid coolers, and this depends on the model you have. So if you have a 240mm model, it will be compatible with both the mainstream and the high-end desktop platform from Intel. So both with, for example, C490 platform, but also X299. Of course, it also works on older Intel CPUs, like if you have a 9th generation or older, with the 1151 socket. It's also compatible with those. For AMD, the 240mm model is compatible with AM4, FM2+, FM2, FM1, AM3, 3+, AM2, AM2+. But if you want to use high-end desktop platform from AMD, so that will be socket TR4, STRX4, or SP3, then you will need to have the 360mm model. And the reason for this, that we only include the brackets for the 360mm models, is that these type of processors, they need a stronger cooler basically to have them run cool. because they have more cores, they produce more heat because of that. And a larger cooling capacity in that situation is necessary. So that's why only the mounts are included in the 360mm model. Diablo is asking, does the LGA 1200 require a different bracket than 1151? No, it doesn't.
No, exactly
same bracket.
Exactly the same bracket.
So also if you have an 1151 cooler, it will also work with 1200. But of course, make sure that the cooler is strong enough. So if you're coming from, for example, a 6-core processor on 1151 and you're upgrading to a 10-core on 1200, then the cooler you had might not cool sufficiently for your new processor. So make sure your CPU cooler is strong enough.
Yeah, there will be a big difference, especially when you go for the high-end socket 1200 CPUs. There will be big difference in temperature and big difference in wattage.
Yeah, later on we'll also show a little bit more about what the power draw of these new CPUs is, so you also know like what the difference is and why it is better to go for a bigger cooler in certain situations. But let's first talk about the MPG Max iHub. That one is included with the models that have an H attached to the model name. So you have the MAG CORELIQUID 240RH, that one comes with a hub. If you have the MAG CORELIQUID 360RH, that one comes with a hub. If you only have the 240R or the 360R, then it's the same cooler, exactly the same specifications, but it comes without this hub. And what this hub does, it will give you a 4-port fan hub with 4-pin headers, so PWM fan connector. It will also give you a 4-port addressable RGB hub with the 3-pin headers that we just saw. That's also used for the addressable RGB lighting of the fans, of the pump, etc., or the CPU block, etc. It also has a thermal sensor in there, so it also comes with a sensor that you can, for example, place in between your cooling of VRM, for example, to measure VRM temperatures or whatever you like to measure. So yeah, thermal sensor included in there. You connect it to the hub, and you can read it out on your computer. It also has Mystic Light support, so you can control this hub completely through the Mystic Light feature in Dragon Center. PWM support, so if the temperature allows it, your fans will spin down a little bit. If your system needs more cooling, they will spin up. So they will base your cooling on the temperature. It is SATA powered, so there is a cable included in the box that has a DC power connector on one side, a SATA connector on the other side, so you can easily connect it to any power supply that has a SATA power connector, and nowadays that's any power supply. And it's USB Type-C controlled, so on the very bottom of the hub you see a small USB Type-C connector, and that one goes to the USB header on your motherboard, so you don't have to connect it on the outside of your case, because of course you will use this hub inside your case, but you can just connect it to your motherboard using a header. Okay, so that's the hub, and this is where a lot of people were very curious about pricing and availability. So we already talked about the different models. We have the 240mm and 360mm, and for both you have a version with the hub and without the hub. So the versions without the hub, so the 240R and the... I thought I changed it. Did I open the right presentation? I see there is a mistake in my graph, because now it shows 240R. Let me quickly check something.
But the pricing is correct, right? Yeah, it says 240R, but I think you did a copy-paste error.
No, I adjusted that.
Oh.
You can entertain them while I fix this, because I need the right presentation, obviously. Oh.
I can show you some different brackets with this. You got the brackets for your Z490 socket 1200 and TRX. Oh, it's a bit difficult to see. Can I show you here? Yeah, maybe. Yes. This for TRX 40. And your AM4 brackets, and they connect to the plastic clips already on your motherboard. so it can fit on any standard motherboard.
I was just a little bit distracted.
Yes, a little bit. He was ghosting.
I was just making sure I'm presenting the right information.
Yes, that would be nice. That would be nice. So you can connect this cooler to any platform from the last, let's say, 8 years or so. So even if you got an older motherboard, you can still use a brand new fancy cooler with this. Oh, here's the other part of the bracket. I
fixed
already.
it.
Oh, you fixed it. Oh, by magic.
Yeah, it's important because we have some more stuff to show you. As I told you, the 10th gen Intel Core processors, they were just launched today. So like 2 hours ago now. So I quickly added in some slides as well about this new processor generation. So later on we'll talk about that more. So it was important that I quickly switched presentation. So that's why I knew I had the wrong one. So now you have the right graph as well. 240R 360R will be available in the 3rd week of June. Did you have anything more you wanted to show about the mount, by the way? Because I'm just totally...
Yeah, we're mixing it up a bit.
Breaking into your story.
Yes.
First finish your story. Okay.
Oh yeah, that's better. The close-up camera. That would be nice. The mounts for your new Z490, but can also be used on your older, say, Z87 maybe?
Hussein Hani is asking, why not showing it on test bench? We will.
We will, yes.
If you look carefully in the background, you can actually already see it.
Oh yeah, it's here. Yeah, look.
It's right there.
Yeah, that's Z490. Waiting. Your AMD brackets. Not going to show this today. Not on a platform at least. And also your TRX 40.
Yeah, so this one only comes with the 360mm model.
But that's by design, because you need the higher capacity of cooling for the TRX 40 CPUs.
We have a question in chat. Can we only control the fan speed with the hub? Can I not control it without the hub and only the motherboard? No, also with the motherboard you can control the fan speed, but it will not be as extensive as what you can do with the hub. You will obviously control them all through one PWM header. So with the hub you have more control, both of your RGB and your of your fans, and you can also connect the thermal sensor to it. Ragnarok's asking, what's the difference between the H and the HR, the RH version? Sorry, the R stands for RGB. All of them have RGB, so all come with the R. The H stands for the hub that is included or not. So the 240RH and the 360RH both come with the MPG MSI hub in the box. And the models without the hub will be available in the 3rd week of June. This is an estimate, so this depends on the region where you are. In some regions it might be available a little bit sooner. In other regions it might take a little bit longer. But approximately the 3rd week of June is when you can expect these models. The 240RH and the 360RH, so the versions with the hub, are expected by the end of July. So if you want more detailed about more detailed information about the availability, make sure to check it with your local reseller. I'm sure they can provide you with more information about this. And here you can also see the prices. So the 240R is $129 MSRP, so that's excluding VAT. The 240RH with the hub is $149. Then you have the 360R at $169. The 360RH at $189, and the prices in euros, and those are including VAT, so big difference here to note. Of course, prices can differ per country. Also, VAT differs per country, so that has an influence. In this example, we're using 20% VAT. It might be slightly higher, slightly lower in your region. Also, these are recommended prices, so your reseller can decide his own price. Can be slightly higher, can be slightly lower. But this is approximately what you can expect. Also, on the 16th of June, we will launch a promotion with these coolers. So you can get a nice Steam voucher when you buy one of these coolers. And if you get it in a combination with a Z490 motherboard, you will get a higher value voucher. So make sure to keep a close look on our website if you're interested in one of these coolers, because you could get a nice Steam code with it. So on the 16th of June, this promotion will go live.
I saw somebody was asking about the i9-10900K, if this cooler can cool this up to 250 watt. Yes, it will. And we can show you later, because we're gonna overclock the 10900K.
So that's the top model in the 10th gen Intel Core processor.
Yes, and at that time it should reach about 275 watts about, and this should keep it cool. But we're gonna show you later.
But let's first show maybe with a case, where you
Yes.
can position them inside the case.
We got here.
We're not going to build it completely inside the case. That would take a little bit too much time, and we also want to show some benchmarks, of course, with the 10900K CPU, the Core i9 10 core on a Z490 motherboard. Someone in chat is saying Turkey is 47 degrees Celsius, very hot. So yeah, but that is actually an important factor, because
Yes.
if you live in a country where it's quite hot, then you might need a bigger cooler than in other countries. So for example, if you live in a colder country, a 240 millimeter radiator might already be sufficient. But if you live in a very hot country, make sure your cooling is sufficient. So here we have our MPG Secura 500X.
Yes. Yeah, 500X, yes. Easy to open, slides out. Store it somewhere. Oh. This is a really big radiator, but it's still easy to mount in the system, because you can slide out, oh, I can show you. Slide out the top rail.
And of course, the way you can install it depends on the case. So make sure, if you're interested in one of these all-in-one water coolers, make sure to check if your case can actually hold the size of the radiator.
Yeah, you connect your radiator and fans to the slide. I don't want to screw it in right now, but then you can slide it just back in, and it easily fits on top. If you don't want it on top, it's also fine, because there's also space.
Mark is asking, does it come with brackets for Threadripper? The 360 millimeter models do, yes. But the 240 don't.
It's a bit more tight. You don't want to show it in the front. It's easier to put it here on top, because then it has two large fans on top to get rid of the air. And you put the three fans here on the bottom.
And make sure that if you install a radiator, for example, in the top of this case, keep in mind what your airflow will look like. Because in this situation, if you, for example, pull the air from the inside of the case and want to push it outwards on the top, then in this situation you will need to turn the fans around on top. Because now the fans are pushing down air, so they're intakes at the moment, and they will push against the other fans, so the heat will get trapped in your radiator. So make sure, if you have fans on top and on the bottom, make sure they're targeting the same direction.
Yes. So normally you want to have the air flowing out through your radiator, so you put the fans on your radiator this way up, so it pushes air this way. Standard in this case, the fans are, for the looks, positioned to have the airflow in from the top, flowing down. So
yes, they're intake fans, basically.
Intake fans. So it's more done for looks in this case, because it has a really nice big glass panel on top. But if you want the best cooling, you just flip these around, so they're used as outtake fans, so the air blows this way. But make sure the radiator, the big radiators, fit in your case, because it doesn't fit in all cases. So make sure you check that first. You can have it, in some cases you can have the radiators fit in front. If you fit the radiators in front of your case, like here, and have air pulling inside, it normally keeps your CPU cooler, but it will dump the hot air inside your case. So you need good extra fans in the case. If you put the radiator in the top, it takes the warmer air inside the case, pushes it through the radiator out the top. That's, in most cases, it will have a little bit warmer CPU, but it's also used as a airflow fan then.
I see a couple of questions in chat. What's the name of the case? This is the MPG Sakura 500X.
Yes.
Espin the Red Dragon is asking why didn't MSI put a VRM cooling fan on the CPU block? Interesting comment. In this situation, for example, we're now using the MEG Z490 ACE motherboard, and that one already has fans on the VRM. So they're semi-passive, so they will only spin if they actually need to, otherwise they'll work passively. So if the VRM temperature is below 70 degrees, they will not spin. They will only spin up if the temperature rises above 70 degrees. So here you already have semi-active cooling on your VRM. So no need to also put it in the water block in that situation.
Yes.
Of course, this depends a bit per model, but also including a fan there will obstruct the looks a little bit. So we think it's better to position it in a spot where you cannot see them. Basically, they're hidden underneath the I/O cover. So they provide cooling, they don't obstruct the looks, and it looks very clean with just a water block on top of your CPU. Let me see if we have more questions. Ragnarok's asking, how can I know if it's compatible with my Antec torque case? Make sure to check on their website what types of radiators fit inside that case. Usually, for example, if your case has got 2 fans in the front or 2 fans in the top, they can usually go up to 240mm radiators. If you can accommodate 3 fans in the front or the top, you can usually also put a 360mm radiator in there. But make sure to check radiator compatibility with your case vendor.
Yeah, and in some cases you can fit the fans in the top, but you don't have enough space to the motherboard, so then it won't fit a radiator and a fan. So also make sure you check that. So maybe in some cases it can fit 2 fans, but not the depth is not enough for a fan and a radiator. So it all depends on the case. So please check with your case manufacturer.
Yeah.
If you
really look at, usually you can also see the information for radiator support. So not specifically fan support, but also radiator support, and that's very useful to see if your case can accommodate a certain water cooler or not.
Fans are usually, so like this one, are 25mm, and our radiator is 27mm. So in total, you need 52mm of space.
What does the fan hub exactly do? It can control RGB and it can control your fans. So for example, you can attach multiple fans to it. But also if you're using the hub in between, you can, for example, with the cable, you can only need 1 4-pin header that you can connect to the hub, but the hub still has got 3 more headers left. So you can also connect your case fans to the hub, for example. So you don't need as many PWM headers on your motherboard. With the hub, you also have a 4-port hub in there. For the addressable RGB as well, you can connect multiple RGB components in there. For the water cooling, you can of course daisy chain them, so you only need 1 connector. But if you, for example, also have, let's say, LED strips or other RGB fans that you want to connect, you can attach them to the hub as well. So it basically expands your options. And of course it has a temperature sensor included.
Yep.
Yeah, let's take a look at the new Intel CPUs maybe, because we will test it with these. But
you want to? Only the CPUs? Yes, only the CPUs.
I have a very nice overview with. These are not all 10th gen Intel Core processors. These are the i9 and the i7 models. Later on, we'll also show the i5 and i3 models. But as you can see, compared to the previous generation, the 9th generation, you can get more cores now. So the 9th generation went up to 8 cores with hyperthreading, 16 threads. So for example, the 9900, the 9900K, 9900KF, KS, etc. They're all 8-core, 16 thread. But now you also have the 10900K and the 10900KF and the 10900. They all offer 10 cores with hyperthreading. So yeah, more cores will give you obviously more multi-core performance. Clock speeds are also a little bit higher, so you also get a little bit better single core performance with this new generation. The TDP differs per CPU, of course. If you have a K-SKU, your TDP is a little bit higher. Of course, you can overclock with those. You cannot with the non-K-SKU. We also see that memory support is a little bit higher compared to the previous generation. So with the 9th generation, you could do up to DDR4 2666, I believe, from the top of my head. And with this generation, you can do 2933. So that's
only on i7 and i9. i5 still is 2666.
Yeah, we'll see that one in the next one, indeed. I also have an overview for i5, i3. And of course, it doesn't mean that this is the maximum DDR frequency you can run. This is the native DDR4 frequency that these processors support. But in many situations, you can go far beyond this, dependent on your motherboard. But especially if you have like a motherboard with 6 or more layers, you can usually get way higher memory speeds out of them. The models without the F attached to the model name also come with integrated graphics. The 630 in this situation. And the prices, of course, differ per model. If we go to the next page, so this is the i9, i7. i7 is 8-core, 16 threads, so that's basically what was i9 in the previous generation. And then if we look at the i5s and i3s, we now see they also have hyperthreading. So the i5s are still 6-core CPUs, but now with hyperthreading, so you have 6 cores, 12 threads. And for the i3s, they're quad cores with hyperthreading, so they will give you 8 threads. And here you can indeed see that the memory support for these models is up to 2666 megahertz, whereas for the i7 and the i9, the native memory frequency is 2933. Okay.
Yeah.
Then let's talk a little bit about performance, because these, actually the performance graphs, they're allowed to be online a little bit over 2 hours now. So this is extremely new information. So we borrowed some results from Hardware Info, a Dutch media, and they tested 2 models, the Core i9 10900K and the Core i5 10600K. So they're a 10-core and 6-core processor respectively. Both of them have hyperthreading. And here you can see the gaming and the streaming performance. And as you can see, for gaming, the 10900K is basically the fastest CPU you can buy for gaming now. In this graph, you can see the average FPS amongst different games. So they tested a whole bunch of games. They added all of them together, divided it by the number of games, and then you get the average FPS in general. So yeah, you see that the 10th generation Intel Core processors are really strong for gaming. On the right side, you see the streaming performance. And for this benchmark, they're actually running a stream in OBS with a very fast CPU preset, and they do the encoding on the CPU. So they use X264, very fast preset, and then they play the game next to it. And this is quite CPU intensive because, especially if you're gaming, you're both gaming and encoding a live stream on your CPU. So here you can see that there is a huge difference in the number of cores that your CPU provides. Basically, you could say like if you compare, for example, the i9 with the i5, you can see that the i9 is quite a lot faster in this situation because it has more cores and can allocate the power that it needs to encode the stream to those cores. Here you can also see that the CPU, like the Ryzen Threadripper 3960X, of course, high-end desktop platform, way more cores, and it's extremely powerful here because the encoding the stream does not have as much of an impact on a CPU like that. And here you can see that it has quite a large impact if you only have limited cores on your CPU. So the gaming and streaming performance, yeah, for gaming, they're basically the best out there. For streaming, of course, if you have even more cores, you will benefit from it.
10 is not enough.
If you also want to stream through your CPU, of course you can do the encoding on a separate system and run the stream off there. You can also run it off your graphics card. Many modern graphics cards have an encoder built in there, so you your graphics card has a dedicated chip to do the encoding, so the load on your CPU will not be as high as when you do all the encoding on your CPU.
Indeed. This test was specially designed for stressing the CPU very much.
Yeah, here you can. Yeah, I believe there are quite some people that only want to stream on one CPU, and if your graphics card does not have a proper encoder, you will have to do it on your CPU to get a good stream quality. So in that situation, it makes sense, but then you will need a more powerful processor with more cores to spread the workload, basically.
Indeed.
Then the raw performance of the CPU, basically, that's what you can test with Cinebench. And Cinebench has got two tests. This is, I believe, the R21, looking at the results.
It's too small for me to read from here.
Yeah, so we have, for example, on 10900K, 533.
I think so. It's single core, it was 533 or so. Yeah, that's single-threaded Cinebench R20.
Yeah, exactly. So on the left, you see the single-threaded. On the right, you see the multi-threaded. So this Cinebench R20. And like you can see, in the single-threaded performance, they're a little bit faster than the previous generation. So the 10900K is a bit faster than, for example, the 9700K, 9600K, and single-threaded. Of course, the number of cores does not matter because it only runs on one core. So there's a slight increase in the single-threaded performance here. The i5 also slightly faster than the i5 of the previous generation in terms of single-core performance. But where you see the real step is in multi-core performance. Of course, the 10900K has got more physical cores than the 9900K. So you see quite a big step up in multi-core performance. And also for the i5 10600K, you see quite a bump in multi-core performance. And that's not because of the number of cores, because it's still 6 cores, just like the previous generation Core i5, but now it's got hyper-threading, and that makes a big difference for your multi-threaded performance.
Yep.
And then the power consumption, and this is also where the cooling comes in, because if you have a higher power consumption, the CPU will generate more heat, and you need to dissipate that heat through your CPU cooler. So you can see in idle, the power usage is extremely low. It's only slightly higher than the previous generation, but on load, it's quite a bit higher. So in this situation, they put load on the CPU through Cinebench, so they're really stressing the CPU. This is, by the way, the average power consumption in Cinebench. So not the maximum. Sometimes you have a short period where it's a little bit higher, but this is the average power consumption. And as you can see, for example, the 10900K is more power hungry than the 9900K. Of course, it has more cores. It will also boost a little bit further. So you see that in your power consumption, and that's really where your CPU cooling comes in, because it will also give you a higher performance. Later on, we'll also show you something, because the 10th generation Intel Core processors have something called thermal velocity boost, and that basically means that if your processor temperature is below 70 degrees, I believe, from the top of my head,
yeah,
correct?
Exactly 70 degrees.
Yeah, so if it's below 70 degrees, it will basically unlock an extra boost mode that will give you more performance. If your CPU temperature is above 70 degrees, then thermal velocity boost will not kick in. So it will still be, they're still fast CPUs, but you will get extra performance if your cooling is better. And that's, for example, something we also know from AMD. They have Precision Boost Overdrive, and it also kicks in based on your CPU temperature. It can give you extra performance. So more cooling can also give you more performance in this situation.
Yeah. And that's what we're going to show you in a little bit.
Yeah. Here we see an overview of the Core i5, the Core i7, and the Core i9 of the 10th generation with different voltages. So you see that on the bottom, you see the multiplier. That times 100 is the clock speed. So, for example, with 37, it's 3.7 gigahertz. 3.7 gigahertz.
Yeah, that's the base clock of the 10900K.
Yeah, that's the base clock indeed. That's why there is also a square around it. And then you see the boost frequencies on the right. So with a multiplier of 48 and 49, so that's 4.8 gigahertz or 4.9 gigahertz, dependent on the model you have, of course. In blue, you see the...
now that's with thermal velocity boost on and off. 4.8 gigahertz with thermal velocity boost off. If you above 70 degrees.
Yeah.
And if you're below 70 degrees, then it will kick to 4.9 on all cores. And then, yeah, thermal velocity boost kicks in.
Yeah, so in the line you see the voltage on the CPU, and in the bars you see the package power. So that's basically the power consumption of the CPU. And of course, if the CPU increases the frequency with boosting or through thermal velocity boost, you will also see an increase in the power draw of the CPU. So like we saw in the previous overview, for example, the 10900K under full load, in this situation does an average of 200 watts in Cinebench. And here you can also see that if you overclock it, for example, to 5.2 gigahertz, so that's with 52 multiplier, there you can see with the Core i9 you can even go quite far beyond 200 watts. And that's what we also later on will demonstrate to you. We also have like a power measurement device, so power meter, so we can show the power draw, the difference in power draw with, for example, thermal velocity boost on or off, etc. Okay, so let's continue with some demonstrations, I think.
Yes, time for the test bench.
It's definitely time for the test bench.
First, we're going to show you quite a good, air cooler. And later on...
Just dropping all the mess in front of me?
Yes, yes, because I need some space.
Oh, my giveaway system is working.
Oh,
and I can see who our first winner was. So if you haven't participated yet, go to msi.com/2/insider to participate. The bot will also spam the direct link to Gleam in the chat once every now and then. And the first winner of our giveaway is Aaron. Congratulations, you won a $20 USD Steam Wallet code. And you were the one for the previous drawing, but because it took a while before the notebook decided that Aaron was the winner, I will also draw a second winner right now. And I'm not sure if that will also take very long, but then we will just, with the next giveaway, we'll announce this one.
Yeah, the last one, it took about an hour for it to work.
Half an hour.
Half an hour, okay. Yeah,
but quite long. And it looks like now it will take a while again. So hopefully in half an hour I have the next winner ready for you. So first we will show you the system running with an air cooler. So this is the Core Frozr S installed on there.
Yeah, that's this one.
So this is, I would say, like quite an average sized air cooler.
Yeah,
it is, of course, it's an aftermarket cooler, so it's bigger than, for example, you're used to from boxed coolers. It's a tower model air cooler with a 120 millimeter fan. And I would say, like, for general gaming usage with a moderate CPU, this is perfectly fine. But if you're going to use a very high-end CPU, and also you want to have stuff like thermal velocity boost, then you need more.
Yeah, this is quite a nice cooler for your average setup. But if you really want all the performance, you might need a little bit more. Let's see if we can have some picture.
So first we will demonstrate what the temperatures are like with the 10900K under the Core Frozr S in this situation. And later on we will install the MAG CORELIQUID 360R on the exact same system. And we will also run some benchmarks on both, so you can also see what difference in performance it makes when you, for example, have thermal velocity boost kicking in.
We've got here in this system, it's a Z490 ACE motherboard with an Intel i9 10900K, yes. And 2 times 8 gigabytes, 3200 megahertz Corsair memory. So just it was high-end memory a few years ago, but now it's almost back to the base clock of the Intel CPUs. So Intel CPUs run at base 2933. This is our high-end memory from a few years ago, 3200, but you can run a lot faster memories if you really want to.
Yeah, and especially on a motherboard like ACE, it can do way higher memory frequencies than 2933 or even 3200.
Yeah, I think 4600.
Yeah, should be. Of course, it very much depends on your memory modules.
Of course.
but yes, the motherboard can do that. For example, this motherboard has got a 6-layer PCB. All our Z490 motherboards have at least a 6-layer PCB, so they're all quite strong on memory speeds, I'd say. And our ITX model even has a 10-layer PCB, and the Godlike has an 8-layer PCB, so they have even more layers that usually gives you an even clearer memory signal and allows you to get even higher frequencies.
Yes. On this system we're going to run Cinebench R20 multi-core. I've got it over here. Let's start it up. And I am going to show you also the CPU temperature. The CPU, okay, let's see, this is CPU temperature. This bar, at the moment it's 31 degrees because it's idling. The CPU package power is the top one. The CPU only draws about 13 watts. 8 should be around 10 watts when idling. And here you can see the core ratio. It's at 8, so that means it's 800 megahertz because it's idling. And when I start the test, click run and show you all the numbers, you can see the temperature rises to now 74 degrees, 75. So it's getting quite warm, 76. CPU package power, the top one, it's now 184 watts. So it's drawing quite a lot of power. And you see the CPU core ratio is at 48, so it's 4.8 gigahertz. So it's not running at its full potential, at least not thermal velocity boost. It's not working because we're above 70 degrees. Actually, we're at 82 at the moment.
So like these kind of temperatures, they're still safe, but
yes,
it does mean that certain boost features will not work anymore. In this situation, thermal velocity boost.
Yes.
So you can get higher performance by getting that CPU temperature down.
Yeah, it will run perfectly fine for all day, but you will lose a little bit of performance because it will run only at 4.8 gigahertz.
Which is still fast, by the way, but
yes,
it's not the maximum you can get out of it.
No, it's still faster than the previous generation, actually.
My chat is struggling a little bit, so if you're questioning why I'm not answering questions right now, that's one of the reasons.
RAM frequency over 9000, that would be good, yes.
That will be quite complicated at this point. Let me see. Burby is saying, what's the GPU? Right now we have a GTX 1660 Ti, the Ventus model in there.
Yes.
Ventus XS.
It's not a super high-end model, it's middle of the range.
But we're not really going to do too many game benchmarks.
No.
Only one to show the load on the CPU. So this is just for demonstration purposes. It doesn't matter as much what GPU you have when you're benchmarking the CPU. And
in this benchmark you can see the multi-core score is 6128. And the plan is to remove this tiny cooler. Actually it's not that tiny, but it's not really huge.
It's like a moderately sized cooler.
Yeah, it's for some PCs it's quite big already. And we're going to replace it with...
This is already quite a bigger cooler than what you would get, like a stock cooler that comes included in the box.
With a 10900K, you don't.
There is none in the box anyway. But for example, with some other SKUs, you will get a cooler in the box, but that's way smaller than what we're using right now.
Yes, indeed.
So it is already the Core Frozr S is already quite a.
It's already a big
cooler.
Upgrade over your stock cooler, yes. But and it works fine with the 10900K, yes. But your CPU can run better when you include something like this for better cooling, even better cooling. For fun, I'll run the test again, just to show you the temperatures and the powers. So it's quite a lot of power that needs to be cooled. It's 184 watts, only the CPU. And if I can have a close-up maybe, the wall power meter, just the whole system, is now at 241 watts. There's a whole system, this including graphics card, motherboard, SSD, memories. So that's really a lot for only CPU. And we're not even
because
using
now the graphics card is completely in idle. There is not running anything significant on the GPU right now.
No, GPU uses now probably less than 10 watts.
Yeah.
The test is almost finished. It's now finished, and it goes back up to about, say, 50 watts should be for full system.
So here you can also see what kind of difference it makes nowadays in between the TDP and the actual power draw in situations like Cinebench. So the TDP of the 10900K is 125 watts, for example. But if you're going to put full load on 10 cores, then it will draw way more. So also the VRM of your motherboard becomes more important. The cooling of your CPU becomes more important. So definitely something to take into account if we're going to use a CPU like this, because they can go quite far beyond 125 watts.
Yeah, easily. This one was at, let's see, 189 watts maximum.
Yeah.
So that's a bit more than 125, I would say. But it's also running quite a bit faster than 3.7 gigahertz. It's running at 4.8.
And with thermal velocity boost, you can even get to 4.9.
That's what we're going to show later, or actually now. After I put on...
Yeah, first put it on maybe, that helps.
I think so too. I think it's time for the new cooler.
Take it away.
Let's turn it off, shut down.
So then we can also see how you apply the thermal paste to it.
Yeah, there's of course already a bit of thermal paste on there. So only needs to add a little bit more.
Let me see if we have some more questions.
Yeah, now it's question time.
Now it's question time, but
and Michiel will answer them all.
My chat is struggling. I see some. Michael's having a question. What's the radiator thickness fin count? I see the radiator thickness already in chat. 27 millimeters. The fin count. I didn't count them myself. I don't know actually.
A lot.
A lot. A lot of fins.
A lot of fins.
And also a lot of micro fins in the copper plate of the CPU block. Travis is asking, when the GPU isn't idle, let's say Valorant as an example, how many watts would the GPU be using? Of course, depends very much on your GPU.
No,
but the 1660 Ti, I would guess from the top of your head, 1660 Ti power usage?
I think almost all NVIDIA GPUs uses about 10 watts.
No, I mean in a game, he says.
Oh,
like in Valorant, for example.
Oh, in game. 1660 Ti, it should be 130 watts?
Yeah, approximately. I think that's quite close indeed.
And it doesn't really matter which game.
But of course, it depends on your GPU a lot. If you have a faster GPU than a 1660 Ti, it will usually draw a little bit more power. A more entry-level one will not draw as much power. So first, remove the air cooler.
Yes.
I'm going to see if I already have another winner. So if you haven't participated in the giveaway yet, go to msi.com/2/insider. My giveaway system is still struggling a little bit, but still make sure to participate. But because even if the drawing doesn't work now, I can see everyone who entered and I can still draw winners. So then I will just draw them after the stream if I'm not able to get any more winners during the stream. And we're giving away several $20 Steam Wallet codes. So the giveaway is on Gleam. The more actions you perform there, the bigger chance you will have to win. You can find the direct link to Gleam also in chat. The bot spams it every once in a while there. No, my giveaway system is still struggling. So that's the whole mount of the air cooler.
Yes, the mount of the air cooler. Quite a big mount for the air cooler.
Yeah, with the back plate also.
Yeah, metal and a plastic protector. So.
Making some space.
Make some space. And find all the parts because it's now covered all over the desk. We need these. And we need the bag of screws.
And of course the way you install it on the motherboard is dependent on the type of socket you use. So if you use this, for example, with a Threadripper CPU or an X299 model, then your mount will of course be different. And that can also make a difference in the way you have to install it on your motherboard.
We've got screws for TRX40. We're not going to use this today. Screws for socket 2011. Not using it today.
T-Day Kid is saying, giveaway struggling, maybe you need to add the CORELIQUID 360R to it. Yeah, then I'm sure it will completely crash.
They
we
really
gave away one 2 weeks ago. Maybe we will give one away more in the future, but for now there are $20 USD Steam Wallet codes.
If you look in here, you can see the little flat side at the back plate, and the screws also has a little flat side. You need to fit that together. And it should fit like here.
Arashi is asking, what is he building? Peter is currently installing the MAG CORELIQUID 360R water cooling onto the motherboard. In this situation, the MEG Z490 ACE with a Core i9 10900K CPU.
That's the plan, at least. There are a lot of screws because you have got a lot of screws for the fans and more screws for mounting.
So in this example, it's an
fan,
LGA 1200 mount, so that's the same as the LGA 1151 mount.
Yeah, I'm thinking. I didn't read the manual, so I'm just guessing.
You didn't read the manual?
Do I need to?
You always need to start reading the manual,
no.
so you know what you're doing.
No, I'm just guessing. That's more fun.
I hope it's an educated guess.
Yeah, I was telling you about the holes, but I forgot already, and I'm doing it wrong, so that helps. There are two sets of holes. Holes on the outside and a hole on the inside. And for a socket Z490 you need a hole on the inside, because the holes on the motherboards, those here, are a little bit differently spaced than the holes you need for for X299 or socket 2011. Because are you going to use the same bracket actually?
I think so.
Yeah.
I think the other holes on the bracket you're now using are for X299, I'm guessing. But
no, that would be silly.
Yeah, you think you have a different bracket for X299?
Oh no, these are the holes. This is the bracket for sockets 1366, probably.
Ah.
Because the bracket for, sorry, the holes, the screw holes for sockets 2011 are built into the socket.
Ah, yeah, like with, that's also what you get, for example, with Threadripper.
Yes.
You have to screw it basically on the existing socket instead of placing a backplate.
So I was mixing it up. I was confusing myself.
In this situation, you will need to put the backplate on there yourself.
Yeah, and you put a slide on the little plastic cover so it holds in the screws and keeps it properly spaced. So when you've done that, it should fit all the holes.
Fits like a glove.
Fits like a glove. If it doesn't fit, probably you picked the wrong holes and you should recheck it.
You should read the manual, basically.
Oh, you should read the manual, maybe. Yeah. No, I'm not going to do that. You got the little plastic spacers. You slide them over the top. Like all over the top, and that will also hold in the backplate so it won't fall down. So now it's easy to put in the motherboard into your case and put in the water block later if you want to. But I'm not going to put it inside the case. These ones are for your AMD sockets. Not going to use this today.
So that's, for example, what you use for AM4. So they're not used for Threadripper.
No,
Threadripper also has like the mount already onto the socket, so you can directly mount the cooler onto the socket. But for AM4, it uses these kind of clips on the sides. And these clips you can also attach to the parts of your motherboard.
Now I think I'm going to put on the fans on the radiator. I like that first.
You just hit me with the radiator, did you notice?
Yeah, oh yeah, again. Yeah, we're not allowed to sit close together.
Now, of course, due to the current situation with the coronavirus, we need to keep distance from each other. That's why I'm actually sitting around the corner currently from Peter. So I just pasted myself into the screen.
Yeah, he's faking it.
I'm faking it, yes. The saying is, fake it till you make it, right?
Yes. For fans and radiators, it doesn't really matter if you put the fans this way around, if you want to put them on the other side blowing into the radiator, if that comes out better in your case, or even if it's spooling through the radiator, so air goes that way, or on the other side. The performance is all the same. There's maybe a maximum 1 degree difference in some setups, but in average, just make it look cool, make it how it fits in your case. Now I like to have them pushing into the radiator, but if your style is to have it drawing through the radiator, that is also fine.
And of course, what you can do if you want to improve performance, you can, for example, do a push-pull configuration.
Yeah, this
so
is a push-pull
on both sides.
Pushing, and one on the other side, pulling the air through. But that makes it really, really thick.
Yeah, it makes it really thick, but it will give you a little bit of performance increase.
Yes, a little bit.
Yeah. So it can be interesting, for example, if you're just short on cooling capacity to have thermal velocity boost on. That might push you over the edge that you keep your processor underneath 70 degrees. And then it could be interesting because then you will unlock a little bit more performance basically.
Yes.
Yeah, so this is the downside of a 360mm radiator. You have to screw 3 fans on.
Yes, I could skip some screws, but yeah, I like them all in.
It looks better with all of them attached.
Yes.
Edwin K is saying it seems like liquid metal cooling paste cools the PC 5 to 10 degrees Celsius. I think you mean like the difference with regular cooling paste. Depends a little bit on the situation, of course, but also with liquid metal you have to be extremely careful because where regular thermal paste, if it's in a spot where it's not supposed to be, it's not that dangerous. That's different with liquid metal, so be very careful when you apply it. And also, if you use liquid metal, you have to replace it more often than when you use regular thermal paste.
Yeah, if you use regular thermal paste, you normally apply it once, and after 3 years it's still okay.
Yeah. With liquid metal, you want to repaste your system every now and then, because in the beginning it will indeed give you a little bit better performance than regular cooling paste. but if it's older liquid metal thermal paste, you will lose a little bit of cooling performance.
Let's see.
Site is saying, any comments on pull fan on that radiator? Yeah, you can do it. It makes your radiator a bit thicker, of course. Yeah, not the radiator, but the complete package with the fans. But it will give you a little bit better cooling performance if you do push-pull. So it's up to you. In many situations, you don't have to use push-pull. But if you want to really get the maximum out of the system, then you can add it.
Yeah, and if you just want to know if you mean only pushing or only pulling, it doesn't really matter for performance.
And that's it. No, it barely makes a difference.
Let's see. It should slide on like this.
So it slides basically around the block.
It's that easy.
And then you hear a click, and then it's properly attached.
Yeah, then it's properly attached indeed. And then we need the motherboard again. Oh, and the screws. Don't lose them. There's already a little bit of thermal paste on there, but I think I'll just add a little bit more in the middle. We've got some bulk thermal paste because that's what we always use. But the standard thermal paste included in the package, if I have not lost it, probably I have now. Oh, here. This is the one you already get with the system, but it's not easy, not recommended to mix thermal paste. Otherwise, you need to clean it first.
And now you also need to clean your hands.
Yes, that's also that was why I wasn't paying attention.
Do you have something to clean your hands?
Yes, yes, yes.
I got some paper. Good.
And you can do it in some different ways to put on the thermal paste. I just normally do just some blob in the middle.
And by applying pressure through the mounting system, it will automatically spread over the CPU basically.
Yes, indeed.
And if you, for example, have an AMD Ryzen Threadripper CPU, they're quite a bit bigger and the cores are also spread over different places on the CPU. So there, if your CPU is that large, it's usually not recommended to do only one blob, but make sure to have thermal paste applied to different parts of the CPU to make sure that the thermal paste also reaches all parts of the CPU.
Yes, indeed. But these CPUs...
Yeah, these are relatively small CPUs.
Yes.
Like a 10th generation CPU is exactly the same size as the 9th generation, 8th, 7th, 6th, etc. Rock is asking, what do you use to remove the old paste?
Normally just some tissues.
Yeah, and if you really want to clean it properly, you could use a little bit of acetone on top of your...
Yeah, then you can make it shiny again, but for normal applications just use some tissues and then it's clean enough.
It should be okay.
Make sure you don't put thermal paste in your socket or on the underside of the CPUs where the contacts are, but yeah, that should be...
should speak for itself.
Yeah, should.
Should.
Let's see, memories. I put them somewhere, but I don't know where. Oh, here. See, I lost my memory, where my memory was.
Your long-term memory or a short-term memory?
In this case, short-term.
Okay.
We've got a lot of cables for the fans and RGB, and I'm just untying them all because they all got the little clips on them. And I'm going to try to connect them all to the motherboard. I'm not trying, I know how to connect them all to the motherboard. Because it's quite easy if you got rid of all the little things.
So many cables.
Many cables.
Per fan, you have 2 cables. One
Yes.
is for the fan spinning, the other one is for the RGB lighting in the fan. The one that the fan is spinning is very important, so the one on the left in this situation, and the other one, of course it looks better when you connect it because your RGB lighting is working, but it does not have any influence on the performance of the cooler, so it's not a disaster if you forget to...
Oh no, RGB makes your PC faster, right?
Oh yeah, that's true, a lot faster.
A lot faster.
So make sure to connect it because more RGB gives you more frames.
Also, the water block has RGB connector, so you connect one part to the motherboard, to the J Rainbow.
Fluffy Panda is asking, what's the motherboard chipset? In this situation, it's Intel Z490.
Yes. And the water block has a breakout cable, so you can connect the first fan, and that fan also has a breakout cable, so you can connect the second fan. Remove the little cap. And then the last fan, and then all the RGB should be connected. Oh, not anymore. If you put it from
You're
the motherboard.
popular, you have so many fans.
So many fans. And then you got all the cables for powering the fans, and one last cable for powering the pump. Also a little thing on there. For powering the fans, we need the cable with all the splices in there. So you connect one to your motherboard, and you got 3 to connect all your fans. So that also makes it easy. So one here, and one here, and one here. And this one connects to your CPU fan header on top of your motherboard. And then we've got one last connection to make, and that's for the water pump.
Alan says it's hard to find alcohol, might have to order it in like Amazon or somewhere. Yeah, if you want pure alcohol, that's usually harder to find than
Yeah.
beer is not that hard to find.
Don't clean your CPU with beer.
No, don't. If you want to clean it with alcohol, use pure alcohol.
Yes.
If you cannot find alcohol, you can also use acetone, something like that. But in many situations, it's perfectly fine if you just remove the thermal paste with a tissue or something.
All right, should be all connected. At least. See, many cables.
Ramen Rider says maybe vodka. I think that's already a better idea than beer.
Oh, vodka? Maybe now you should
I
drink
wouldn't
it.
recommend it, using it, but if you would decide between vodka and beer, I would go for vodka. Yes. Not to drink, but to clean your CPU. Michael says one drawback to proper cooling: cables, cables, cables.
Yes.
Yes, and also RGB lighting, because now you have to connect all the cooling cables and all the RGB cables. So yeah, it will take some time to do proper cable management.
Yes, it will take some time indeed to make it really nice in your PC case. Actually, it's not super hard, because normally
usually now it's an open setup, but when you would have this in a case, you can, for example, route the cables to the back of the case, where you can easily get them behind your motherboard, and there you can manage everything easily. So it's out of sight. Now it looks like one big mess because everything is open and you can see all the cables.
Yeah, indeed. Normally you hide everything behind your motherboard.
Yeah, in a computer case, this is a lot easier to hide. No, my giveaway system is down again.
No
So
giveaways?
I will draw the rest of the winners after the stream, or maybe tomorrow when it's back up. You can still participate, of course. You can still enter the giveaway. Go to msi.com/2/insider, or follow the direct link that is spammed in the chat on, for example, YouTube and Twitch. Make sure to participate, because even though I'm not drawing the winners live, I will still draw these winners, and they will receive a $20 USD Steam Wallet code through their email in the coming days. So you might get an email in the coming days, and then you were lucky. Marciano Gaming is asking push and pull performance. It does not make much of a difference, but if you want the best performance, then you can add extra fans to have push and pull simultaneously.
It should work now. Should I try it?
Yeah, that's a good idea, I would say.
Yeah. Let's see. Click. Lights work.
The lights work.
Yes.
So you have many FPS because the lights work.
Of course it turns off, but that's normal. Yes.
Siak Games is saying boo scam. No, don't worry, we'll still give out the codes. We're not scamming anyone.
No?
We just cannot announce the winners right now because we have to draw them after the stream. But the giveaway doesn't change. Don't worry. And maybe it's even nicer that you don't know that you won, but then you look in your email box and you might have a nice $20 Steam Wallet code in there. That would be a nice surprise, right?
Actually, it is. I think so.
So does it work?
Yes. Can you show them?
You didn't destroy anything.
Not yet.
Oh, good. Seems to work.
Seems to work. Not faking it. No, it's the real system.
Yeah, prove it. Wiggle your mouse.
Oh yeah.
Yeah. Okay. Confirmed. It works.
Okay. Can you show you? No, you cannot see the screen here. There's a screen on my side.
Yeah.
What's shown on? Yeah, what you can show here. Let's see.
For the rest, the setup still 100% the same. So we're
Yep.
still using the Core i9 10900K, 10-core CPU, 20 threads.
Yeah, same CPU, same settings, same
exactly.
everything. Different.
Same
cooling.
motherboard, same memory.
Yep. Same SSD, same software.
Different cooler.
Different cooler. Okay. Small cooler. No, not that small, but smaller cooler.
Smaller cooler, yeah.
With one 12cm fan, and here the big one with 3 12cm fans, and a lot of water. We're going to do the exact same test as we did before. We're going to run Cinebench R20 multi-core, but now cooled with a CORELIQUID 360R.
Yeah, so we run the multi-threaded version, so it will use all cores. So this will also give you maximum load on your CPU. And what was the power draw again?
It was 189 watts with a smaller cooler running at 4.8 gigahertz. And the score, I cannot remember, it's like 6,128 was it before, I think.
Now we should be able to get a little bit higher score because with this cooler we can use thermal velocity boost, right?
I hope so.
Should be if you if you mounted it properly.
Yes, I think so. We'll see. We are running, and now the test starts, and I can see I didn't mount it properly. Yes. Maybe I made a classic mistake. Did I?
Did you?
I think I did.
What did you do?
Oh, this is the real classic mistake. Don't ever do this what I just did.
But that's good, so other people can learn from your mistake.
Can you guess what I did? I need to turn it off.
You need to turn it off?
Yes, I need to turn it off.
You forgot to connect something.
No, I forgot something.
Forgot to screw the block properly?
No, I didn't forget that.
So what did you forget?
No, I forgot to remove something.
You forgot to remove the plastic thing?
Yes, I never forget it. But
live on stream?
Live on stream I do. It must be.
Now you can use the excuse, yeah, this is so you can learn at home not to do this.
Yes, because that's
a good excuse, right?
Yeah, it's a really good excuse. Like you saw on screen, it was just running at 100 degrees just before I stopped the test. And yeah, that's not good. That's what happens when you do it wrong.
So here you see the difference, what it makes when you don't remove the plastic in between.
Yes. I never made this mistake my entire life, and live on stream I do. Nice. I like it. Let's see if I'm right. Oh yes. Look.
So this is our technical expert, right?
Yes. I've been only doing this for about 20 years. Look, nice and clean. So don't forget to remove the plastic. Do as I say, not what I do.
Travis is saying in the chat, this is why we read the manual, chat. Exactly. And I told Peter to read the manual,
actually,
but he didn't.
It says on the sticker itself. Let's see, it says, please remove before install.
So you didn't read the manual nor the sticker.
Indeed. So
you just put it on there.
But actually, it was perfect. Can you do the close-up?
Yeah, how it spreads over the...
Yeah, it was perfect application of CPU paste, thermal paste.
So here you can see what the pressure does in spreading the thermal paste over the CPU.
See, this was actually the real test, right? This was what I wanted to show.
Yeah, sure.
Need a little bit more thermal paste in the middle, not to trying to make
Because you just took half off with the plastic.
Yes. Yes, I did.
Our camera has a little bit of trouble focusing.
So, try again.
Now without the plastic in between.
Indeed, indeed. It's such a rookie mistake to make.
So how long have you been working with computers now?
Yeah, I think 25 years, I guess.
There's a first time for everything.
Yes.
Read the manual.
Indeed, indeed.
I told you, but you didn't want to listen.
No, I know.
Raymond Ryder is saying, I've seen those spread tests before. X method seems to be the most effective pasting method. Yeah, it doesn't really matter that much, especially for this kind of CPU when it's so small.
Yeah.
Like you could see on the plastic, the thermal paste was perfectly spread all over the CPU. So in this
for
situation,
bigger CPUs, yes, you might want to do the X.
Yeah, but for this situation, it barely makes a difference.
All right.
Someone's asking in YouTube chat, why does it look like he just used toothpaste?
Because it's white thermal paste.
Do you also brush your teeth with this?
No.
No?
No.
Not recommended?
It's not recommended, no.
Not minty?
No, but actually you could use toothpaste as a thermal paste. It will work for about an hour, and then
Probably. And then it would dry out.
And then it will dry out, and then it will overheat your CPU. So maybe don't do that also. But let's try again.
People are saying cheap paste. This is actually pretty good thermal paste, the white one.
It's not that expensive, no.
Yeah, it's quite affordable, but it works fine. Yeah, there are of course slight differences between different types of thermal paste, but usually the differences between them are in general quite minor.
But we want to show the difference in cooler performance, not the difference in thermal paste performance. So that's why I'm using the same thermal paste on the smaller cooler as on the water cooler. It should work now.
Michael R is asking, what's that wallpaper? Where can I get it? You mean the wallpaper right here? Custom made, you cannot get it. Maybe you can make a screenshot and put it on your background. I will post for you, so I'll be included. Will work, right? So how are your temperatures now? Does the system still work?
Yeah, it still works, of course.
Let's see if it gets over 100 degrees again.
No, it should now just be below 70, I hope.
That's of course the target, because then we get the thermal velocity boost to 4.9 gigahertz.
Yes, indeed. Again, the top graph shows CPU package power. The middle graph shows CPU package temperature. And the bottom graph shows the CPU speeds, at least of the first core. So if it says 51, then it's running at 5.1 gigahertz. Now it's showing it runs at 8. So it's running at 800 megahertz because it's still idle. And I think
this is, for example, what you can also see in this graph is you see the multiplier on the bottom, and that times 100 will give you your speed in megahertz, basically.
Yes, indeed. Let's run the test. Run and show you the information.
So the test without the protective film?
Yes. CPU package temperature is now 59 degrees. 58, 60.
And with the protective film it was 100?
Yeah, that was 100, yes.
And with the previous cooler, the Core Froster S, it was a little over 80, I believe?
Yeah, 82.
82.
But the most important in the bottom graph, you can now see it's running at 4.9 gigahertz instead of 4.8 with a smaller cooler.
So that means now, because of the lower temperature, the velocity boost, the thermal velocity boost kicks in, which will increase your clock speed and your performance.
Yes, and it should run a bit faster.
So we should see a higher score.
Actually,
what was the score
a
in the
lot
previous
faster.
one?
6,128.
Okay. You have good memory.
Yes. Yeah, you can look it up back in stream if you don't believe me. I think it was that one. And now you can see here a score of 6,297. So 170 points more with only changing the cooler.
Yeah.
And maximum temperature now is 62 degrees. So
and this is still on stock speed, but especially if you're going to do overclocking, then a cooler becomes even more important. So if you're going, for example, for a case queue, like this 10900K we have here, but also the 10700K or 10600K, they can be overclocked, they're unlocked. And if you're going to do that, then of course it makes sense to buy a 360mm model over a 240mm model, for example.
Indeed.
If you're not going to overclock then, and you're using a more entry-level CPU, then of course 240 model can be perfectly sufficient, and maybe even overkill already.
Indeed. So the difference between the smaller cooler and the big cooler is exactly 20 degrees Celsius. And also the package power, it draws a little bit more power because it's running at a bit higher speed.
So because the thermal velocity boost kicks in, higher frequency, a little bit more power.
A little bit more power. It's now using at least this CPU, 206 watts under load. We can also show you. Do you still got the graph with Cinebench scores of the older CPUs, like the 9900K?
Let me take a look. This one?
That's the power consumption, the scores.
Oh, the scores of the Cinebench.
Yeah, Cinebench scores. In the right graph, it shows.
Yep.
I cannot read it. The screen is too far away. It's like 3 meters away almost.
Well, let me make it bigger for you. 6357.
6357. That's still faster than this one. But they use different types of memories, I know for sure. I believe
for this test they even use custom water cooling.
Yeah, they also use custom water cooling, and they used low timing memories, and that also makes a bit of difference.
And maybe also faster memory. I'm not sure in this test.
Not sure what they're doing.
Because we're using quite basic memory modules in this situation.
This is quite basic, yeah. High end a few years ago, but not so high end anymore. We could also run the older Cinebench version if you really like to.
The bear is saying I have 120mm cooler and 9700 non-K model. All cores running 4400 megahertz full load and never run higher than 50 degrees. The power draw of the 9th generation is a little bit lower than of the 10th generation.
No, it's a lot lower.
Yeah.
I think his power draw...
Let me pull up the graph again.
I think his power draws will only be, I would guess... Oh, it's a non-K, so it's a 65 watt CPU.
Yeah, so the power draw will be even quite far below the 9700K, and that's not even half of what the 10900K does in Cinebench, for example.
Yeah, but he's using a non-case CPU.
Yeah, but the case queue is already approximately half of what the 10900K is.
Yeah, that's about right. So that makes the biggest difference, the power draw of the CPU.
Yeah, definitely.
And this generation is the power draw of the top-end CPUs is quite a bit higher.
So for example, if you only use a 120mm model that you're using now, and if you would put a 10900K underneath, it will run, but your temperatures will far exceed 50 degrees. Like what we also saw in our demonstration with our air cooler, for example, it runs fine. It was a little over 80 degrees, but it's okay for normal usage. But if you want to make use of thermal velocity boost, or if you want to overclock your CPU, then definitely go for a little bit more beefy cooling.
Indeed. If you're running a lot of single-threaded workloads, I'm going to use Cinebench R15 because it's a bit faster.
Yeah, so R20 also has a single-threaded benchmark, but it takes quite long because it will render everything at one core, basically.
Yes.
So it will, in this situation, you have a 10-core processor. It will take almost 10 times as long.
Yes.
So that's why we're using R15 for this. It's a little bit a shorter benchmark, so we'll not waste as much time by showing this.
You can see it runs only one core, and if you're running only one core, then you can see a power draw will only be like 41 watts, the top graph.
So that's a huge difference.
That's a huge difference, yes.
So you can also see that on Cinebench itself, you see only one square going around. That's the one core that is rendering each part, basically. If you have the multi-threaded benchmark in Cinebench with this CPU, you will see blocks for every core.
Yeah, for every core and every
thread.
Every thread,
so in this situation, with a 20-thread CPU, you will see 20 blocks.
Yes.
If your processor doesn't have hyperthreading, then you will only see the number of cores you have physically in your CPU. Blastero is asking what kind of thermal paste is with AIO. So included?
It's
We can show it up close.
Nope. A little syringe with gray. Let's see. Alright, come on. Don't make a big mess. It's you can spread it quite easily, but I don't know what kind of brand or model it is.
So no fancy names on the tubing?
No fancy names. No, it's MSI brand, of course, because it's included in the MSI box.
Yeah, and we're not using it now, so no idea how this thermal paste exactly performs, but I'm sure it's perfectly fine.
Normally it should all be fine.
Yeah, but because we didn't use this with the air cooler to have a fair comparison, we're using the same thermal paste as we did with the air cooler.
Yeah, and I've got the other one in bulk, and this makes it easier.
Yep.
Like, it's this small versus this big.
Because you use quite a lot of thermal paste, right?
Almost every day a bit, yes. I think the large tube.
Every morning and every evening to brush your teeth?
To brush my teeth, yes.
Marciano Gaming is saying, I'm happy with my Godlike Z390 and i9 900K, waiting for the 10900K and Godlike Z490 to arrive. Greetings from Lima, Peru. I think the Z390 with the 900K is already a very nice combination.
But this is better.
But yes, the 10900K.
2 more cores.
Yeah, you got more cores. Newer Godlike motherboard.
Yes.
But definitely a nice combination.
The test has finished. The CPU power draw is only like 45 watts over the whole benchmark. So that's quite a lot lower than the multi-core benchmark.
Yeah, because with the thermal velocity boost, it went over 200 watts.
Yes.
220, or what was it?
No, only 208, 209.
208,
I can show you, like, and also the speed difference in the test between single core and multi-core. Like, it's so fast. But now it's also using.
The Bear 13 is asking, do you guys think I should upgrade soon to a 360mm all-in-one and i9-9900K soon? Depends on what you're at currently, if it's worth the upgrade. Also, now you have the 10th gen Intel Core processors available. Do you still want to go for the 9th gen? You might be able to get a good deal on them, of course.
Yeah.
So it depends a bit. If you can get a good deal on a 9900K, it can still be well worth it.
It all depends on price.
Yeah, and also what you're searching for. If the 2 cores extra really make a big difference to you, then of course go with the 10th generation.
If you want the best performance, for gaming.
And also keep in mind, like the 9900K is an 8-core processor with 16 threads because of hyperthreading. That's the same as what you would get on Core i7 of the 10th generation. So if you have a 10700K, that will be quite similar to an i9-9900K. So if you compare the pricing, I think it will also make sense to compare the 9900K compared to the current price of the i7 10700K.
Indeed. I think I also want to do a quick overclock, a small overclock only, but to show you the difference between 4.9 gigahertz and all cores and 5.1 gigahertz, and how the small overclock makes a big difference in power usage and still a performance increase, but maybe not as big as you might expect.
Yeah, because that's always the thing with overclocking. Of course, you will get more performance out of it, but the power draw of your CPU will exponentially increase. So this means that a 10% overclock, so 10% higher frequency, will give more than 10% extra power draw.
Yeah, a lot more.
A lot more.
Because we're only going from 4.9 gigahertz to 5.1 gigahertz.
And the power draw is what will require a stronger cooling. So if you do a 10% overclock, you will need way more than 10% stronger cooling.
Yes.
So that's very important to keep in mind if we're going to do overclocking. So that's why we also recommend, if we're going for a K SKU of the 10th generation Intel Core processor, so the overclockable models, then definitely consider to go for the 360mm model instead of the 240mm model.
Indeed.
Because there you can really benefit from the extra cooling for overclocking.
I changed now the CPU ratio from automatic in the BIOS from automatic to 51. And 51 means it will run at 5.1 gigahertz.
I'm not
maximum.
able to capture the BIOS, unfortunately, with our capture card.
Doesn't it work?
No, it doesn't work.
No, I'm already restarting. Do you want to show? I can show you again.
No, I believe the capture card doesn't support the resolution that the BIOS
Oh,
uses.
okay.
So
but I can show you.
Yeah, now it gets back on because you're booting Windows.
I can show you in the tool that is running at 5.1. It's dynamic, so it still drops back to 800 megahertz. But when the test runs, I can show you it runs at 5.1. You can see already it's running at 5.1, and that takes a little bit of time of all the Windows processes to finish starting up.
So this is an overclock of 300 megahertz compared to the regular boost frequency.
Yes.
And 200 compared to the regular, or the frequency with thermal velocity boost
Indeed.
kicking in.
Oh, no, not that one. This one. And just wait till all the Windows processes are finished. It doesn't really matter actually. But you can see previous test on 4.9 gigahertz was used 208 watts of power, And now we're gonna see how much this will be. And you can see it's now up to 255 watts CPU only.
And now you can see that in Cinebench you have all those blocks. Every block is a thread in this situation. So every thread will calculate a different part of the image.
This is the whole system power. 333 watts. Without overclock it was running at 245 watts or so.
Yeah, and please note this is the full system power without having a specific load on the GPU. So there's only load on the CPU right now. The GPU is idling, so if you would also put a lot of load on your GPU, the total power draw of your system will be quite a lot higher.
Yeah. Can you show the desktop? Yeah. The test is just finished. Package power maximum is about 257 watts. So that's about, for CPU only 50 watts more. Temperature is a little bit higher. It's now over 70, maximum 78 degrees. But it doesn't matter for thermal velocity boost because
you're already beyond that frequency.
Yeah. We locked the frequency at 5.1, or actually we didn't lock it, we still have it dynamic because it's now dropping back to 8. But it was running all 5.1 gigahertz all the time.
And now it drops back to reduced power when it's not needed.
Indeed.
Because it's not calculating anything. So.
And as a bonus we get a little bit extra speed. So now we've got a score of 6,565. So that's about 200 points more.
Yeah, so you do see a slight bump in performance, but the increase in power draw is bigger.
Yeah.
So keep that in mind with your cooling, that it is sufficient if you're going to overclock.
Yeah, I can remember a question early in the stream, somebody asking if it can cool 250 watt CPU. This is running of using 257 watts and it's only 76, 78 degrees.
So yes, it can.
Yes, it can.
Right now, right now you see the frequency dropping, so because it's idling, frequency is a lot lower. And what's the temperature right now?
At the moment, that's hopping around 23 degrees.
Yeah, so you can see that it's a huge difference whether the CPU is idling or under load. Actually, these CPUs are very efficient in idle. They have very low power draw.
Yeah, only 9 watts.
Yeah, so that's extremely low. But it can get over, in this situation, over 250 watts if overclocked. Oh, Michael's asking, I was asking about where can I get that wallpaper currently on the computer you're benchmarking.
Oh, that's on MSI.com/wallpapers.
That one you can get.
Yeah.
So MSI.com/wallpapers.
Yeah.
And apply it on your system as well.
This one, right?
Yeah.
Yeah, I just downloaded it yesterday from the website. I like this one.
Yeah, I like it as well. Looks cool.
There are more cool designs on there also.
And this is what you basically have on top of the water block.
Yes. Oh, but you can turn it. Haha. See?
Yeah, so depending on how you install the cooler, you can always make sure to have it the right way up. Okay.
Yes.
Maybe we can do a little bit of gaming to see what that does for the CPU power draw.
Yeah, that's quite interesting also, because when you game, it doesn't use all the CPU all the time at full load. Only for rendering tasks like Cinebench or video editing or rendering. And
also many games cannot even use 10 cores simultaneously.
No. So most games you use only like 2, 3, 4, 5, maybe 6 cores.
Yeah, 6 is basically like...
Yeah.
If you go beyond that, you can still have a faster CPU, for example, in terms of frequency, but it will not give you that much more gaming performance. So on a 6-core CPU, you can expect close to similar performance in gaming than a 10-core CPU. But of course, if the tank or CPU runs at a higher frequency, it will be slightly faster.
So what I've got on here is an older game which has a benchmark inside. That's Metro Last Light. It's a really good benchmark still, even on new CPUs and new graphics cards. And compared to most games, it uses quite a lot of CPU, but I can show you how much it will use. 1080p max settings, and during the benchmark you cannot see it, but I will run the sensors on the background so we can see it afterwards.
Brandon Potter is asking, would a 240 RH be good for a 700K? It depends a bit on how you want to use your 9700K. If you're running it at stock, a 240 RH will be perfectly fine. It will be well over sufficient for 9700K. If you're going to do overclocking on your 9700K, then it can make a difference. Of course, depending on how far you want to overclock, how extreme you want to overclock. But then, if you're going to do overclocking on it, I definitely consider going for the 360 RH in this case. So, can you show the power draw in the close-up, maybe?
I don't think so. Not that it can run. No, then it won't run, I think. Metro Last Light. It's I could try, because.
No, I mean in the close-up cam with the.
Oh yeah, the full system power draw. Mm-hmm. Oh, maybe I can. Yes. Oh no, it crashes. No, it didn't. Let's see. Oh.
So now you can see that even though the graphics card is actually under load, the power draw is still a lot lower than what we just saw with in Cinebench with the overclocked CPU.
Yeah, the graphics card is now on the full load.
Yeah.
And the CPU, not so much, but we'll see how much it will be. It's a test.
So now the CPU power draw is a lot lower than it was while running Cinebench.
A lot lower, yes. I would guess it should be around 60 watts.
Brandon says, I don't like to overclock, I like my safe zones. In that situation, yes, the 240 RH is perfectly sufficient for the 9700K.
Yes. But if you case support 360, maybe it looks cool to have a 360.
It depends a bit on what you want also. Another reason that you can consider choosing the 360 is to have the fans running at a lower RPM, so it can be more silent than a 240mm model. But in terms of cooling, the 240mm model is strong enough for running
easily.
A 9700K at stock easily, yes. Does Intel provide stock coolers with the new i5-10600K? I'm not sure about the i5-10600K.
I don't think they
do on any case queue.
Indeed.
I believe they've not been including them for case queues for quite a long time. Because I'm still running it at home. I still have an old 6600K, and I didn't have a cooler included there either. But it makes sense, of course, because a case queue is basically designed to use for with an overclock. So you don't want to use a stock cooler with that anyway, I would say. So now we can see the graph with the power draw during the in-game benchmark.
You can see the CPU package power is 66, 67, 68. And don't forget, it's still overclocked to 5.1 gigahertz, because you can see that's still here. So
compared to
255?
Yeah, over 250 watts, now down to approximately 70 watts,
72, maximum 73, yeah. So that's quite a big difference for gaming only.
Yeah.
So if you only game, maybe you don't need the super high-end water cooling, or just run it at a lower speed.
Yeah, but if you, for example, do a lot of rendering, like what you see in Cinebench, so when you really put full load on your CPU, then the power draw of your CPU will be way higher and cooling becomes way more important.
Yes, indeed.
Okay. So I think we've basically shown anything, right?
I think so too. Yeah, even mistakes. So that's great.
No, you demonstrated how not to do it, right?
Oh yeah, that's a great lesson.
Exactly. So sorry guys that I couldn't draw more winners during the stream because our giveaway system is running into some issues. If you still want to participate in the giveaway, go to msi.com/2/insider. I will draw the winners afterwards when it's working again, so you can still sign up right now. If you cannot see the link there, you can also go to the direct link, which is spammed in the chat by the bot, at least on YouTube and on Twitch it does. For next week, we actually have a really cool topic because we're going to look into the next generation of MSI motherboards. So today we demonstrated a Z490 motherboard, the MEG Z490 ACE. Next week we're not going to talk about Z490. I cannot yet tell you what we will be talking about, but I can tell you that it will be cool. So definitely make sure to tune in next week, same time, same place. Peter, thank you for joining.
Yeah,
thank you for demonstrating how not to install the all-in-one liquid cooler, but also thank you for showing how you should install it.
Thank you.
And for everyone else, hope to see you again next week. For now, have a good morning, afternoon, evening from wherever you're watching, and see you next time.
Yeah, thank you all.
Bye-bye.
Bye.